Good evening, children.
Good evening, ma'am. Good evening, ma'am.
Good evening, children.
Good evening, ma'am.
Good evening, children. Good evening. Good evening. Invisible children.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
Yeah. Yes, sir. Let's start working from the first one. Let's read the first question. Find the number of rounds. Please write down the question, children. Find the number of rounds that a wheel of diameter 7 by 11 meters will make in going 4 kilometers. Write down the first question. Let's discuss that. Write down the question, children. Now, if the diameter is 10 meters, what is the radius? If the diameter is 10 meters, what is the radius? 10 divided
5
by
centimeters.
yeah, 10 divided by 2, 5 meters. Now, if the diameter is 7 by 11 meters, what is the radius? What is
7
the
by
value?
22.
7 divided by 2.
7 divided by 22 meters. Because 7 by 11 is a diameter divided by 2. 7 by 11 divided by 2. So 7 by 11 into 1 by 2. 7 by 11 into 1 by 2, which is 7 by 22. Be careful there. When the diameter is 7 by 11 meters, the radius is 7 by 22 meters. Or we need to find the number of rounds or the number of revolutions the wheel would make in covering 4 kilometers. So when we find the circumference, that's the distance covered in one revolution. Using the radius, when you compute the circumference, the value of the circumference is the distance covered in going one revolution. So for example, it is 500 meters. Let's assume that the circumference of the wheel is 500 meters. Let's assume that the circumference is 500 meters. All right, then how many rounds? Will the wheel make to cover 4 kilometers?
8 rounds.
8 rounds. 8 rounds. The total distance divided by the distance covered in one revolution. So 4 kilometers, that is 4,000 meters divided by 500 meters. 8 revolutions. That's what you have to do. The steps here, please understand. Write down the. So we need to find the circumference of the wheel. The circumference is the distance covered in one revolution. The circumference is the distance covered in one revolution. The total distance that is to be covered is 4 kilometers or 4,000 meters. So the number of rounds will be the total distance by the distance covered in one revolution. Is that over, children?
Yes, ma'am.
No, ma'am.
All right. I'll wait for a minute. Completed. I'm not sharing the material, children. Please finish it in the class. I'm not sharing the material. All right. Look at the second question. See the second one. OPQR is a rhombus. See here, OPQR is a rhombus with area 32√2 centimeters square. So the area of the rhombus is given to us. Or we need to find the diameter of the circle. Or we need to find the diameter. Or maybe if we can find the radius, we could use that and find the diameter of the circle. We are given that OPQR is a rhombus. What is the property of a rhombus? In a rhombus, are opposite sides equal or all sides equal?
All sides are equal, ma'am.
Opposite
All
sides are
sides are
equal. Yeah, but opposite sides only are not equal. All sides are equal. In a rhombus, all sides are equal. So which means OP is equal to PR is equal to QR is equal to OR. That's the first thing. Since it's a rhombus, all the sides are equal. So OP is equal to PR is equal to QR is equal to RO or OR. But what are OP and OR? What are OP and OR to the circle?
radius.
Radius. Yeah, so OP and OR are the sides of the rhombus as well as the radius of the circle. Now, when you join OQ, children, when you join OQ, what is OQ also the radius? When you join OQ?
Yes, ma'am.
OQ will also.
Yes, ma'am.
Yeah, so what happens is now. Yeah, so when you connect OQ, let's have a look at the side of the triangle OPQ. Connect OQ. Let's talk about the side of the triangle OPQ. So OP is the radius. PQ is also PQ is not the radius, but its length is equal to the radius of the circle. And OQ is the radius. Clearly, this triangle is an equilateral triangle. I repeat. So this is a rhombus. OPQR is a rhombus. OPQR is a rhombus is given to us. And we know that in a rhombus, all sides are equal. Now this side OP is a radius. OP is a radius. OR is also the radius, which means if OP is say like 10 centimeters, all the sides of the rhombus will be 10. So since OP is a radius, the length of PQ is also PQ cannot become the radius of the circle, but the length of PQ is equal to the radius of the circle. Similarly, the length of QR is equal to the radius of the circle. Okay, so that's one thing. Now, when you join OQ, OQ is also the radius. OQ is the radius. OQ is the radius. So what happens? What can you say about triangle OPQ? OPQ is an equilateral triangle. Why? Because OR is the radius. PQ, the length of PQ is equal to the radius of the circle, and OQ is the radius. All the sides are equal. All sides are equal. Equilateral triangle. The same thing below. So now this rhombus is made up of the area of the rhombus is equal to the area of two equilateral triangles. The area of the rhombus is equal to the area of two equilateral triangles. So √3/4 a square into 2 is equal to 32√3. The area of this triangle is √3/4 a square. The area of this triangle is also √3/4 a square. Because the sides are the same, no? See here, OQ becomes a common side to both the triangles. So which means the length of OQ is equal to QR is equal to OR and is equal to OP is equal to PQ. The two triangles have the same length. So 2 into root 3 by 4a square is equal to 32 root 3. With that, you can find the radius and hence find the diameter. Please write the question. I'll show the solution, children. Please write down the question. As you write, understand the steps.
Yes, ma'am.
Yep. Is it over?
No, ma'am.
No, ma'am.
All right. Yes, shall we go to the next one?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Look at that question here. This is the third one. This is the third one. ABCDEF. ABCDEF is a regular hexagon. Is a regular hexagon. Regular meaning all the sides are equal and all the interior angles are also equal. ABCDEF is a regular hexagon. All the sides are equal and all its interior angles are also equal. Find the sum of the areas. Find the sum of the areas of the sectors. Children, what you see here are the sectors. These are the sectors. Can you see the sectors here? These are the sectors. I've not marked the angles. These are the sectors. And the sectors are shaded. Find the sum of the areas of the sectors with radius, with R as radius. Okay, so the radius of each sector is R. The radius of each sector is R. What about the center? And centers being the vertices of the hexagon. See, when we talk about a sector, it's a part of the circle. It's a part of a circle. So you must know the center and the radius. When it is a sector or a segment or a circle, you need to know the center and the value of the radius. All right. So that's what is given to you. This figure is a regular hexagon. We need to find, these are the sectors. So this shaded region is a sector with center A and radius R. Please understand this sector. This is a sector with center A and radius R. This is a sector with center B and radius R. This is a sector. What you see here is a sector with center C and radius R. It goes like that, D, E, and F. So find the sum of the areas of the sector. So how many sectors do we have? How many sectors do we have?
6.
6 sectors.
We have 6 sectors. Now this is a sector. Which is the center of this sector? Which is the center of this sector?
Vertices.
Vertices.
No. Which is the center of this sector? This particular sector?
F.
No, that was not clear. Which is the center of this sector, children?
F.
Yes, ma'am.
F. What about the radius of the sector? What about the radius?
R.
Which is the center of this sector? Which is the center of this sector?
D, ma'am.
D. What about the radius of the sector?
R.
R. So the centers are the vertices and the radius of every sector is R units. R units. So given this, we need to find, we don't have to find the areas of the sectors individually. You don't have to find the area of sector with center A, area of the sector with center B separately. You don't have to find it separately. You need to find the total of the area, the sum of the areas of the sectors. You need to find the sum of the areas of the 6 sectors. So given this polygon is a regular hexagon, and given that the sectors are formed with the vertices are centers and radius R, we need to find the sum of the areas of the 6 sectors. So we have seen 2 situations similar to this, children. Okay, so we have seen one in a triangle. I think horses or some animals were tethered to the 3 corners of a triangular field. Remember? Some 3 animals were tied to the 3 corners.
Yes, ma'am.
Yeah.
On 18th, may we discuss question 4.
Very nice. Thank you so much. Yes. So then I think the next class or the same class we had another situation where it was a quadrilateral, and we had sectors formed at every corner of the quadrilateral, the center being the vertex. We had a similar situation with the quadrilateral, and now this is with a regular hexagon. We have seen 2 similar situations. The first one with a triangle, next with the quadrilateral, and here is a regular hexagon. So you should revise now these 3 in a row. Then you understand the connection between these 3. These 3 are similar. The one the first one was about with the triangle, the second with the quadrilateral, and now this is a regular hexagon. Yeah. Now What is the sum of all the three angles of a triangle?
180.
80 degree.
Okay. Sum of the four angles of a quadrilateral?
360 degree.
360.
Okay. Sum of the five. Yeah. Sum of the five angles of a pentagon?
720.
720. Please check and let me know. Please tell me the sum of the angles. The sum of the angles, the five angles of a pentagon.
540.
540. 540. You can divide a pentagon into
N
three
minus-
triangles. You can divide a pentagon into three triangles. Just divide the pentagon into three triangles. They should not be overlapping. Three different triangles. So in each triangle, the sum is 180. So 180 into 3, 540. Else you can use this formula. 2n minus 4. 2n minus 4. Can somebody complete this formula?
Ma'am, n minus 2 into 180.
180. Okay, n minus 2 into 180. So the number of triangles that can be formed in a polygon is 2 less than the number of sides. That's what it means. Okay, let's start like this. The angle sum property, the formula, the expression that is used to find the sum of the interior angles, of any polygon is n minus 2 into 180. N minus 2 into 180, where n is the number of sides of the polygon. N minus 2 into 180. N minus 2 into 180. So we know that the sum of the three angles of a triangle is 180 degrees. Quadrilateral is 360. Now pentagon, the sum of the five angles, the sum of the five interior angles of a pentagon will be n minus 2 into 180. 5 minus 2, n is the number of sides of the polygon. So 5 minus 2, 3 into 180, 540. Why? Because you can divide a pentagon into three triangles. You can divide a pentagon into three triangles. And the sum in each triangle is 180. So 180 into 3. You can divide, we are not, okay, we can divide a hexagon into four triangles. The number of triangles will be 2 less than the number of sides. That's what it is. The number of triangles will be 2 less than the number of sides. So 6 sides, 6 minus 2, 4 triangles can be formed. Each triangle 180 degrees. So 4 into 180.
Excuse me, ma'am.
Yes.
Ma'am, we can divide into two trapezium, ma'am. So 360 plus 360 we can for example.
Yeah, right. Yes, yes. You can divide, you can connect three and say two trapezium and one trapezium. Yes, that's fine. You're right. Now let's see the answer. So you can do it like this. This is what we just discussed. Or you have the formula here, 2n minus 4 into 90. Or you can call it n minus 2 into 180. 2n minus 4 into 90 is the same as n minus 2 into 180. Yeah. And here, see, this is the procedure. So what's the formula to find the area of a sector? Theta by 360 into pi r square. Theta by 360 into pi r square. Theta is angle A by 360 into pi r square. R being R, radius being R itself. The second sector, theta is angle B by 360 into pi r square. This is the formula, right? Theta by 360 into pi r square. Area of a sector. The third sector, the sector angle is angle C by 360 into pi r square. R is R everywhere because the radius of every sector is R units. So now pi r square by 360 is common. So we have angle A plus B plus C plus D plus E plus F in the bracket. And we know that this sum is 720. We know that the sum of the six angles, or we know that the sum of the six angles of a hexagon is 720. Yeah, and On simplifying, 44 r square by 7 square units. Yes, please write down.
Ma'am,
Yes.
ma'am, you told in the last class that the 10th question we'll discuss in the next class.
Areas related to circles, right? That assignment.
No, last class, the last question in areas related to circles only. On Tuesday class, last question we didn't do, you said it was a lengthy one.
Yeah, ma'am. I too remember that.
Okay. Let me just recall. I'll just pull out that material. Let me share that screen. We'll let me finish this and then just recall that. What was it from? Can you just give me some other clue? Did you write on the
Ma'am, it
question?
was like the last 10 minutes of the class in the recording also. If you
Let me check and get back. Yeah. Okay. Give me some time. Let me check. Oh yeah, that semicircle with I think right. One semicircle with two smaller semicircles and a full circle in it. Correct. Yes. Is it over, children?
Yes, ma'am.
Completed?
Yes, ma'am.
Anybody still writing? Yes, you want the question again? Please take down the figure.
Ma'am, could you move to the answer slide, ma'am?
Okay.
Thank you, ma'am.
Yeah. Yes, I want you to do the fourth one by yourself. Read the question. It's a simple one. Write down the question, try it. Once you get the answer, share your answer. You just have to use the formula to find the area of a sector. Area of a sector is equal to theta by 360 into pi r square. How many unknowns there, children, in this entire formula? Area of sector is equal to theta by 360 into pi r square. So area of sector is one thing, theta, and then r. So the three quantities in this, the others are constants. Area of sector is something unknown, is equal to theta. Theta is unknown by 360. 360 is a constant into pi, constant, r square, radius. So the three quantities, the three unknowns are area of the sector, theta, and radius. Of these three, we know two of them. In a formula, in this formula, there are three unknowns. Given any two, you can find the third one. Now, volume of a cuboid is equal to L into B into H. So volume unknown, length, breadth, height, there is no constant. So there are four quantities in this formula. Volume of a cuboid is equal to LBH. This formula has four quantities. So given the values of any three, you can find the fourth one. So supposing you're given the volume, you're given the breadth and height. So of the four, you know three things. Am I audible, children?
Yes, ma'am.
Okay. Yeah. So yeah, children. So volume is equal to LBH. There are four unknowns here. Of the four, if you know any three, say you know volume, you know the length, and you know the height. So you can substitute them in the appropriate places and find the breadth. In the same way here in this formula, area of a sector is equal to theta by 360 into pi r square. Area of the sector unknown, theta unknown, radius unknown. Three quantities. The others are constants. Yes, what's the answer?
Is it 180?
Ma'am, 72 degree.
Ma'am, 72 degree.
I'm 72 degree.
Srinivasan, Shriya, and Parkavi. Was that Parkavi?
Ma'am, Harshita, ma'am.
Harshita, sorry. Okay, Harshita. Okay.
Ma'am, I've shared the working.
Okay, yeah. Let me check. So children, I was telling you that this formula has three unknowns: area of sector, theta, and radius. The others are constants, 360 and pi. So given any two, you can find the third one. Yeah. So see here, this is the formula. Substitute in the appropriate places. Area is given 5 pi. You know the radius is 5. So you just have to substitute in the formula and find the value of theta, which is 72 degrees. Theta is 72 degrees. Yes, complete this.
Yes, ma'am.
Ma'am, I have shared my picture, ma'am.
Yeah, Harshita, I'll have a look. Okay, Srinivasan. Good, Harshita. Good, Shreya, good. Bhargavi, good. And yeah, nice. 5 children have shared their answers. Very good, children. Yeah, so that's about the 4th one. See the 5th one. Let's understand the information given. Arc A is a part of the circle. Don't read it ahead of me, children. Understand what I am reading. Please don't go ahead of me. Arc A is a part of the circle with center O and radius OP. Okay, arc A. This is arc A, children. This is arc A. Can you see this A here? So this is arc A. I'm moving the cursor over it. This is arc A, children. Arc A is a, so when it's an arc, it's a part of a circle. So which is its center? What is the radius? These are the immediate questions. Okay, so arc A, arc is a part of a circle. So which is the center of this arc, or the center of the circle of which the arc is a part? Which is the center? What is the radius? These are the questions. So that's what is given to you. Arc is a part of the circle with center O. All right. So with O as center, and see the radius is given. Radius OP. Okay. So with O as center and radius OP, that is 10 centimeters. This arc is described. This arc is described. This arc is described with O as center and OP as radius. All right. So what is this, children? What is this figure OPQ? What is this figure OPQ?
Sector.
It's a sector. It's a sector. Correct. It's a sector. OPQ. OPQ is a sector. It's bounded by 2 radii. It's bounded by 2 radii and an arc. All right. Arc B. Arc B is a part of the circle. Yeah, an arc is a part of a circle. Now, arc B is a part of the circle with center M. So see here, it's not the same center O. Arc B, this arc B is a part of the circle with center M, and radius PM and radius PM. And this is the radius. This is the radius. This is the center and PM is the radius. That is 5 centimeters the radius. So arc B is a part of the circle with center M and radius PM, where M is the midpoint of PQ. That's also given to us. M is the midpoint of PQ. All right. What do we need to find? Find the area enclosed by the two arcs. Find the area enclosed by the two arcs. So that means between them, enclosed by the two arcs, meaning the area between them. So this area is what we have to find. This area is what we have to find. See here, the area enclosed between the two arcs. This is one arc. This is the other arc. The space between them. This one. The area between them, not the space. The area between them. So see, everything is given to us. There are two arcs. Or we know the center, we know the center of arc A, and we also know its radius. Or we know the center of arc B, and we also know its radius. What else you need for an arc, which is a part of a circle? Center, radius, that's it. Now you're good to go. You just have to find two things and subtract and get the answer. I'm not explaining this. I want you to do it yourself. Please write down, draw the figure, write down the information. Give you 10 minutes time for this. After writing the question, 10 minutes after writing the question. Write the question now. All of you kindly draw the figure. Don't be in a hurry to start working the answer. You will be given time for that. Please draw the figure neatly. And don't draw a very small one. Children, some of us are into that habit. We draw a miniature figure. A very small one. You can even draw it bigger than what you see on the screen. Don't draw a very small one. Write down the information given and then start working. Okay, Priyadarshini has shared answer 4. Very good, Priyadarshini. Yes, children, you should have finished the question. Now your time to start the answer. So 10 minutes from now. Please use pi as 3.1428 and root 3, 1.73. Yes, who can tell me the sector angle? What is the sector angle?
60 degree.
Why is it 60? Yeah, Srinivasan, why is it 60?
Because all sides are equal, ma'am.
Yeah, which is a triangle?
OP is equal to
Which is a triangle?
OPQ, ma'am.
In triangle OPQ, all the sides are equal to how much?
10 centimeters, ma'am.
10 centimeters. So it's an equilateral triangle, and hence angle POQ is equal to 60 degrees. Have we found the area of the sector? Sector with radius OP?
Yes, ma'am.
What's the answer?
52.38, ma'am.
Very good, very good. Area of the sector is 52.38 centimeters square. Very good. What about the area of the triangle?
Ma'am, I directly found the sector, ma'am.
You directly found?
Yes, ma'am.
Okay, fine, no problem. You did not find the area of the triangle. All right.
Ma'am, area enclosed by arc B is 39.285, ma'am.
Very good. That's correct. And okay, have you completed?
Yes, ma'am.
Okay, so what's your final answer? Area enclosed by arc A and arc B.
That I didn't complete, ma'am.
Okay, fine, fine. Please proceed. Yes. Yes, sir. So these are the milestones which you have to achieve. You need to find the area of the sector. You need to find the area of the triangle. Yeah, it's time. If you're not able to unmute and share your answer, share your picture. Yes, children, please share your answer. Area of the sector OPQ. See the sector. Area of the sector OPQ is 60 by 360, theta by 360, 60. We found this angle is 60 degrees because this triangle is an equilateral triangle. So 60 by 360 into pi r square. Radius is 10 centimeters. And using this value of pi, 3.1428, it's exactly 52.38 centimeters square. 52.38 centimeters square. What about the area of the triangle, children? What's the area of the triangle OPQ?
43.25.
Yes, 43.25. Root 3 by 4 into a square. Now, what's the area of this segment? What's the area of this segment? This segment? What is the area of the segment? What is the area of this segment?
$9.13.
See, Srinivasan does not want to say. He's giving chance to others also. Since nobody is responding, that's really nice. See, he's got the answer. He doesn't want to say because he's waiting for the others also, his friends also to share the answer. Are we all there? No response.
Yes, sir.
All right, children. All right, children. So the area of the segment is the area of the sector minus the area of the triangle, which is 9.13 centimeters square. 9.13. What's the area of the semicircle? Now this one is a semicircle. This one is a semicircle. This one is a semicircle because it's given. 39. Yeah, this one is a semicircle. It's given that M is the, see here, arc B is a part of the circle with center M. M is a center. That means PQ is the diameter. M is the center. That means PQ is the diameter. The center lies on the diameter, right? Now this one is a diameter because M is the center of this arc. M is the center of this arc. So that means PMQ is the diameter, which means this arc is a semicircle. This one is a semicircular region. Now we need to next find the area of the semicircle. Why semicircle? See, this is the diameter. How do we know this is the diameter? Because M is the center. So then PQ is the diameter. This is the semicircle. 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 This is the diameter. Semicircle. Area of the semicircle is equal to pi r square by 2, half of pi r square, where the radius is 5 centimeters, not 10. Radius is 5 centimeters. M is the center, PM is the radius, is all given to us. Nothing is Nothing we have to find, all given, everything is given to us. M is the center, this is the radius. So half pi r square, where r is 5 centimeters, will give us the area of the semicircle. What's the area of the semicircle?
39.25.
285. 39.285. Yes. So now what's the answer? The area of the semicircle, minus the area of the segment will give us the area between the two arcs. See here, this is the semicircle. This is the semicircle. So area of the semicircle, this full thing, minus the area of the segment, will give us the area between the two arcs. This full thing is the semicircle. We found the area of the semicircle, this full thing. From that, if you take away the area of the segment, which we found earlier, when you take away the area of the segment, you will get the area enclosed between the two arcs. Let me share the answer with you. Have a look at it. And then if you have any questions, you can ask me. Please check your answer with what you see on the screen. If you have any questions, please ask me. Srinivasan and Priyadarshini have shared their answers. See, I've told you, you can if you have logged in, through your mobile phone, you will not leave the meeting. You can just minimize the screen and take a picture. You can use the camera. You will not leave the meeting. When you minimize, you will not leave the meeting. Regularly, only few students share. Whose is this? It's a number, so I can't make out. Oh, Shriya. Okay. I don't see much steps, Shreya. You've written something and you striked it out, so not very clear.
Like I didn't.
All right, but anyways, so 3 of you have shared, Srinivasan, Priyadarshini and Shreya. All right, it's any questions, children, regarding this? We understand the triangle is equilateral, so the sector angle is 60 degrees. We need to find the area of the sector and then the area of the triangle. See, this is not new to you, so I'm just reading it out. And then find the area of the segment. That's one part. Then we need to find the area of the semicircle. Its radius, the value of its radius is different. Then we need to, so we find the area of the segment and then we find the area of the semicircle. The difference is the area enclosed between arc A and arc B. So see, we'll see it with the figure again. This is the sector. This is the sector. OP radius, OQ radius, and this is the arc. The sector has this triangle and segment in it. Sector has a triangle and the segment in it. So area of the sector minus the area of the triangle will give us the area of this piece, this segment. Have that answer. Find the area of the segment, have it with you. Next, find the area of the semicircle. Now this one is a semicircle. This is a semicircle because the center of arc B is M and MP is the radius. MQ is the radius. Because P and Q are points on this arc B. P and Q, P lies on arc B, Q also lies on arc B. So MQ and MP are the radius. So which means this is a semicircle, this is a diameter, so which means this full thing. See from here, from the diameter till this portion, this is the semicircular region. So find the area of the semicircle and take away the area of the segment which you found earlier. That will give you this area, which is the area enclosed between the two arcs. Everybody still to see the answer? Please tell me.
Yes, ma'am.
Finished?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
All right, children. All right. See the sixth one. See six. This is the sixth one. There's a right angle here, children. You cannot see it. There's a right angle here. Okay, this one is a rectangle. It's given to us. ABCD is a rectangle. Is given to us. ABCD is a rectangle. ABCD is a rectangle. And yes, I must tell you, this is a semicircle. This one is a semicircle. This one is a semicircle. You can just include that information. This is a semicircle. All right. So O is a center. O is a center. This is a semicircle. And then ABCD is a rectangle. ABCD is a rectangle. So given this, you can see here, take pi as 3.14. Take pi as 3.14. The question is to find the area of the shaded region. Area of the shaded region. That is, the shaded region is a part of the rectangle, not including the area of this portion. It's the area of the rectangle, but not including this. So which means it's the area of the rectangle outside the semicircle. You need to find the area of the rectangle outside the semicircle. The shaded region represents the region of the rectangle or the area of the rectangle outside the semicircle. Outside the semicircle. That's what we have to find. Yes. Take down the figure. First is you'll have to get the idea, the procedure to that is the path which you have to take to find the area. So that's what you should first decide on. How do I handle the situation? So once you get that idea, then if you have to find the area of a sector, immediately the questions come. What is the center? What is the radius? And all such things. So first understand the procedure. What is the path you need to take to get the answer? Okay, Manasa has also shared her answer for the fifth one. Good, Manasa. Yes, have you understood the procedure to find the area of the shaded region?
Yes, ma'am.
Yeah, tell me.
Ma'am, area of the rectangle minus area of the segment, ma'am.
Yeah, okay. Area of the rectangle minus area of the segment. How do we find the area of the segment?
Theta by 316.
Which is a sector? Name the sector. Name the sector here.
AOL,
OA. Okay, AO. Okay, OAEB. Okay,
Yes.
OAEB. This is the sector. Now, what does the sector have in it? It has two things, right? The sector has
Radius and angle. Triangle and a segment.
Yeah, so the sector is made up of the sector, or any sector is made up of a triangle and a segment. Okay, so that's right. So we need to first find the area of the sector, and from the sector you should take away the area of the triangle to get the area of the segment. And then, as Arnav said, area of the rectangle minus area of the segment will give us the area of the shaded region. Yes. Step 1, to find area of OAEB. OAEB, which is a sector. That's correct. That's the first step. Step 2, find the area of the triangle. Step 3, find the area of the segment, which is the area of the sector minus the area of the triangle. Step 4, find the area of the rectangle. Step 5, area of the rectangle minus the area of the segment will give us the area of the rectangle outside, or the area of the shaded region. Now that you understood the path, so you understand that this is the path you need to take to arrive at the answer. Now come from the beginning. How do we find the area of the sector? What are the values you need to find the area of the sector? What do we have in the formula? Area of sector is equal to theta by 316 to pi r square.
It's an isosceles triangle.
What is the no? Yeah, that's what I wanted to excuse myself. Don't go by the way the triangle looks, children. You must be able to justify. Okay, it's an isosceles triangle. That's what. So don't go by the way the triangle looks, because it's a free hand.
Because OL is equal to 10 root 2 and OL is equal to OA because it's the area of the radius.
Correct, but that's true in any sector. All right, that's true in any sector. Every sector has an isosceles triangle in it. Further, the isosceles triangle may be equilateral, but the triangle in every sector is isosceles. All right, so that's what. So now that you know the path, so you need to find the area of the sector. To find the area of the sector, you need two values, theta and r. What is the value of r? What is the value of theta?
Radius is equal to 10 root 2 centimeters.
Okay. Which line segment?
Theta is 60.
Which line segment represents the radius? Which line segment represents the radius?
Ma'am, OA.
Yellow.
OA. LO. Okay. LO is the radius of the semicircle. So LO is equal to OA. Radius
Yes,
of the
ma'am.
yeah, LO. Okay, OL is equal to OA is equal to OB is equal to OM. All radius of the semicircle. See here, OA radius, OL radius, OA radius, OB radius, OM radius, all from the center to some point on the circumference. All right. Okay, so we got the radius. What about the sector angle?
60 degree.
How?
Ma'am, linear pair. LOA plus AOB plus BOM is equal to 180.
But how do you say that these three angles are equal? How do you say that this angle is equal to this angle is equal to this angle? That is true only when these three angles are equal. This angle plus this angle, and this angle. Only if these three angles are equal, then you can use that.
Ma'am, angle AOL is equal to angle OAB, ma'am.
Angle AOL is equal to
Angle OAB.
AB. Okay.
And similarly, angle BOM is equal to OBA, ma'am.
Yeah, reason.
Because this we can take as a triangle AOL as the isosceles triangle.
Okay.
And we already know that triangle AOB is isosceles triangle, ma'am, so that we can make it as equal.
Okay, you're saying this angle is equal to this angle, and this
Yes,
angle
ma'am.
is equal to this angle. But how will that help you to find this angle? You do not know the measure of. You do not know. You know that these two angles are equal, but what is their measure? Equal, they can be 40-40, they can be 50-50, they can be 70-70. They equal, you know, but what is their measure? You do not even know one angle.
Ma'am, we know angle A. It's 90 degrees. That rectangle.
No, that is here, this portion. See here, this one is 90. This one is 90. But what about this? Yeah, rectangle, yes. This is 90 degrees. This one is 90. Angle is 90. So what you have to do is in triangle AOB, OA is 10 root 2. OB is 10 root 2. Find out, children, what is OA square plus OB square? Find out, all of you. Find out OA square plus OB square. We are talking about this triangle. We're talking about this triangle. In this triangle, find OA square plus OB square. Quick.
400 centimeter.
400. Which is the other side of this triangle? Which is the other side of this triangle?
20 centimeters.
No, which
20
is the other
centimeter,
side?
ma'am.
Not like- Which is the other side?
AB, ma'am.
AB.
AB,
What
ma'am.
length of AB?
20, ma'am.
Yeah, 20, because in a rectangle opposite sides are equal. So AB is 20. What is AB square?
20, ma'am.
400. AB square is 400.
400, ma'am.
So what do you observe in this triangle? What do you observe in this
By
triangle?
converse of Pythagoras
Yeah.
theorem, ma'am.
By converse of Pythagoras theorem, which angle is the right angle? By the
Ma'am,
converse.
angle AOB is equal to 90 degree, ma'am.
Yeah, who was that?
Shakti San, ma'am.
Okay, yeah, okay. So angle AOB is equal to 90 degrees. So by the converse of Pythagoras theorem, angle AOB, I told you it's a freehand diagram. So now don't ask me how can this be 90. It doesn't look 90. It looks less than 90. See, it's a freehand diagram. It's not from the textbook, so you have to, adjust there. So in this triangle, OA square plus OB square. OA square plus OB square is 10 root 2 the whole square plus 10 root 2 the whole square. 200 plus 200, 400. AB square is equal to 20 square, 400. So OA square plus OB square is equal to AB square. So by the converse of Pythagoras theorem, angle AOB is equal to 90 degrees because it's opposite of the longest side. 20 centimeters is the longest side. Why did we square OA and OB? Because 10 root 2, the sides OA and OB, their lengths are 10 root 2. It's less than 20. 10 root 2 is less than 20 because what is 20? 10 into 2 is 20. I'm just telling you, like 20 is 10 into 2, but this is 10 into root 2. So obviously OA and OB are less than AB. AB is the longest side. That is why we squared it separately. That's why we squared it separately because AB is the longest side. OA is 10 root 2, OB is 10 root 2, AB is 20. Now, when you look at all the three sides, AB is the longest side because its length is 20 centimeters. So we square it separately. All right. So now by the converse of Pythagoras theorem, angle AOB is equal to 90 degrees. This is one way of doing, children, but you also know trigonometry. You should construct. So we discussed that in the last class. The other way of whenever you have to find the sector angle, please think of trigonometry. Whenever you have to find sector angle, please think of trigonometry. All right. So this work you will do it by yourself. I'll just tell you. I'll just initiate the process. So the construction will be draw say OM perpendicular to AB. Draw OM perpendicular to AB. All right. So this will be a right triangle. You are interested in finding this angle here. So connect this angle with the two other sides, which one side which you do one side, this angle with two sides. This side OA you know is 10 root 2, and here this AE, not AE, we said M, right? So OM we said this M here, AM is equal to 10 centimeters because 20, so it will be 10, 10. The two triangles will be congruent to each other. So connect this angle with 10 root 2 and this 10 centimeters. We'll take this up in the next class, children. I want you to try trigonometry, I said. I'm initiating the process for you. I said draw OM perpendicular to AB. That's the first step. Now, when you draw OM like this, we have two triangles. The two triangles will be congruent to each other. Draw OM. So the two triangles are AOM and BOM. Those two triangles will be congruent to each other. So angle AOM will be equal to angle BOM. Angle AOM will be equal to angle BOM. Now, in one of the triangles, say in triangle AOM, connect this angle AOM with the two sides AO and AM. AM is 10 centimeters because 20 by 2, 10. And this is 10 root 2. This side is 10 root 2. Connect this angle with this side and this side. And find this angle. Use trigonometry and find this angle. You will get 45 degrees. Double to get the complete angle 90 degrees. Maybe I'll share the working later on WhatsApp. I'll share it tomorrow. Try it out End of the class, you can just, like it hardly takes 3 minutes to finish that. Whenever you have to find a missing angle, please think of trigonometry. So you can do this using trigonometry or by using converse of Pythagoras theorem. Yes, children, that's it. So you found this angle is 90 degrees. So now you can find the area of the sector, the area of the triangle. Yes, start working. Have you taken the question, children? Who needs the question? The figure? Okay, start working. Do not blindly copy. We've understood, we have discussed the steps. Please understand everything you write. Completed, children? Still writing?
Ma'am.
All right, all right.
Yes.
Yeah.
Completed, ma'am.
All right.
Completed.
All right, children. Yeah. Yeah, children, see this one. Find the area and perimeter of the shaded region. Find area and perimeter of the shaded region. You can see here OA, this is what is given. OA is equal to OB is equal to OC is equal to OD. OA, where's OA? This is O, children. This is O, this is O, OA. OA, see here, this line segment OA is equal to OB is equal to OC is equal to OD. That's given. So all these line segments is equal to 14 centimeters. And please make a note of this. These are quadrants. This is a quadrant and this is a semicircle. This is a semicircle. You can see two semicircles, 1 and 2. You can see two semicircles and you can see two quadrants. This one is a quadrant. This one is a quadrant and this also a quadrant is given. Two quadrants and two semicircles. These line segments are equal to 14 centimeters. Given this, we need to find the area and perimeter of the shaded region. Find the perimeter. Area is simple. Find the perimeter, children. All of you work the perimeter first. Let's see who can give me the correct answer. I hope you're all finding the perimeter first. Again, we have done similar situations, children. It's not difficult to get the correct answer. It's not difficult. We have seen similar situations earlier. What is the
176 centimeter.
So see, shaded is the two semicircles are shaded and the two quadrants are shaded. The two semicircles are shaded, the two quadrants are shaded. We need to find the perimeter. Yes, Srinivasan, what's it? 1?
Ma'am, it is not me.
Oh, it was not you. Okay, somebody said something. 176, you said?
Yes, ma'am.
Yeah, who's that?
Tirunesh.
Yeah, Tirunesh, 176. Of the 3-digit, 1 is correct, 6 is correct. It's not 176, it's something else. Just check your calculation, or I don't know if you've not worked it also correctly. I don't know. It's not 176. Okay, just tell me the different lengths you have added to find the perimeter. You must have added different lengths, right? Tirunesh? Yes, Tirunesh. The sum of some line segments or curves make the perimeter. What have you added? Okay.
Ma'am, 138.
No. No.
Ma'am, 122.
122. No.
Ma'am, 160.
Yeah, that's correct. 116. I'm so happy to hear that. Very good. 116 is the correct answer. Yes, explain that, Srinivas. How did you get 116?
Ma'am, perimeter of quadrant I took
No,
2 pi.
just put it like this for me. This is O, right? This is O. So just let's just call it like the length of the semicircle, the length of the semicircle, or you can put it like the length of the semicircle with OB as diameter plus. You understand? If you're mentioning the semicircle, just mention the diameter, the length of the semicircle with OB as diameter plus. Something like the length of the quadrant with something as diameter or radius. Yes, tell me.
Perimeter of semicircle with diameter OB is equals to 44 centimeter.
No. We'll come to the values later. I just want to know what the sum of what makes the perimeter. So
Pi r.
no, let's do it like this. So the length of the semicircle with OB as diameter plus
Length of OAS radius.
length of the arc, length of the arc in the quadrant. Somebody's mic is enabled. Kindly disable your mic. So length of the arc in the quadrant with say OA as radius. All right then.
Length of OA.
So plus OA. OA
Yes.
you need to add. No? Should you add OA?
Yes, ma'am.
Okay, then.
Then we should go to CO, ma'am. Arc CO.
Okay, this one then plus
Arc OD.
arc OD. Arc, that is a arc in the quadrant with OD as radius.
Yes, ma'am.
Okay, and then
Plus OD.
plus OD. Very good. Very good. Yeah. So to find that's what it is. You have to find the sum of all these lengths to find the perimeter of the shaded region. See, when it's perimeter of the shaded region, you need to walk along the boundary of the shaded region. Don't get into the figure. Just walk on the boundary. Say you start here. Please follow the pointer. Supposing you start here. So you walk all the way like this. You walk all the way like this. So this is, you're walking on the semicircle. To find the perimeter of the shaded region, children, don't get into the figure. Don't get into the figure. Just go along the boundary of the shaded region. Please walk. Just go along the boundary of the shaded region. So see, supposing you start to walk like this. From O, you take a walk like this. So this is the length of the semicircle. Then you need to go like this. You should not come inside the figure. Don't come inside the figure like this. So you need to go along the boundary like this. This is semicircle. And then you will be traveling you will be walking on the arc of the quadrant like this. You will be walking on the arc of the quadrant. See this arc of the quadrant, and you're at A. Then you need to come like this. You need to walk along AO here. And now again, you need to continue a journey like this. Walk along the semicircle. Walk on the boundary of the semicircle. Walk on the boundary of the semicircle. Then continue. Please follow my pointer. Then continue to walk on the arc of the quadrant. And then on the line segment DO. And see, you come back to the starting point. You started from here. You started from O. You went like this on the semicircle. Then on the arc of the quadrant. And then along AO. And then you again came on the semicircle. And then you walked along the arc of the quadrant, and then on the line segment DO, and you come back to the starting point O. So you walked along the boundary once, boundary of the shaded region once. You should not get into the figure. You're walking on the boundary. So you can start anyways. You can start like this also. You can walk like this on the quadrant, on the line segment, and again, or you can even continue like this. You can continue like this and then come back to the starting point. So the perimeter of the shaded region, and one more thing is perimeter is never something minus something. It's never like that. Perimeter is just will be. I'm sure some of you will might find some perimeter, some larger perimeter, and find some smaller perimeter and subtract the two. No, area works like that, not perimeter. Length does not work like that. Length is you should keep adding this portion plus this portion plus this portion. It's never some bigger perimeter minus smaller perimeter. It's never like that. Perimeter does not work like that. So you keep adding, you're walking along something, keep adding those lengths. So now what you have to be careful is, now you need to be careful about the radius, the value of the radius. What is the radius of the semicircle? What is the radius of the semicircle, children?
7 by 2, ma'am.
7, ma'am.
7. Sorry.
7.
That's where, see, sometimes we may be right with the idea, but then we go wrong in taking the value of the radius. Again, whatever it is, even if your idea is correct, but your numerical values are incorrect, you don't get marks for it. Okay. So be very careful. When it's semicircle, the radius is 7 centimeters because the diameter of the semicircle is 14. The diameter is 14, so radius is 7. It might look simple. You know why she's discussing all this as if we don't know the diameter is 14, the radius is obviously 7. It's not for that. Keep this in mind. We sometimes, in a hurry because you feel, it's very simple. You feel you know it, and then by mistake you take the diameter as the radius. Diameter is 14, radius is 7. So that is for the semicircle. When you're working with the semicircle, the radius is 7. What about the radius of the quadrant, children?
14, ma'am.
What is the radius of the quadrant? 14 or 7?
14, ma'am.
For the quadrant here, because this is O, OB and OA are the radii of the quadrant. For the quadrant, OA and OB are the radius. For the semicircle, they are diameters. For the semicircle, OB is the diameter. For this semicircle, OC is the diameter. So half of it is the radius. But for the quadrant, OB, OA, radius. For this quadrant also, OC, OD, radius for this quadrant. So you just have to be careful there. And then how do you find what is the length of this arc in the quadrant? I just want that expression. How do you find the length of this arc in a quadrant? How do you
Pi r
find
by 2.
pi r by 2? What's the total? What's the length of the circle? What's the perimeter of a circle?
2 pi r, ma'am.
2 pi r. So for a semicircle, 2 pi r by 2. And for a quadrant, 2 pi r by 4. By 4. Pi r by 2. So children, that's it. The length of this arc is pi r by 2. 2 pi r by 4. 2 pi r is for the circle divided by 4 will be the length of this arc. Pi r by 2. Pi r by 2 is the length of this arc. The length of this arc is pi r by 2, where r is 14. The length of this arc is pi r because 2 pi r by 2. 2 pi r by 2. This is pi r, where r is 7. Where r is 7. Similarly, this one also. The perimeter, that is the length of the semicircle. The length of the semicircle is pi r, where r is 7. And this quadrant, this arc in the quadrant, the length is pi r by 2, where r is 14. And then this line segment straight away is 14. This one is also 14. Area of the shaded region, you just have to find the areas of the two semis, or you can find the area of one semicircle and one quadrant, add both and double the answer. Add and double the answer, because you have a similar thing below. These are two identical regions, right? So the area is the same. All right, so let's see the answer now. Again, how simple, you can make your working. See for the, oh my God. Yeah, children, so you can see it here. OA plus length of the arc with radius OA, this description, and then you don't have to write this. You don't have to write this. You can also use symbols, arc. You can use a symbol for the arc. You can even write it in short using symbols. Okay, so see here. Don't take the value of pi. Don't take the value of pi at all. You'll have to add these 6 things. Don't use a value of pi like this. You substitute. Have your answer in pi like this. And once for all, you can use the value of pi. Once for all, you can use the value of pi. 116. Area. Area, is the area of the 2 quadrants plus the area of the 2 semicircles. Area. See, so here calculation is easy, but you should be careful in taking the values. And sometimes semicircle, we forget to write pi r square by 2. Semicircle, area of a semicircle is pi r square by 2. We forget that by 2, we just take pi r square. So there we have to be careful. Yes, children, finish this answer. We need to discuss that other one also, which Arnav reminded us. This finishes this paper. With 7, we finish this paper. So I think we have time to discuss that one, which we did not in the last class.
Amit, can you show the question now?
Question? Yeah, okay.
Yes, ma'am, thank you.
All right. I think by Tuesday we'll wind up with this chapter. Monday, Tuesday. Then the next chapter will be trigonometry. I've already shared the videos with you long ago. Please watch the videos and be ready with the introduction. We'll straight away get into the chapter because the introduction to the chapter is all in the videos. Yes, is it over, children? Is this over?
No.
I think you can just take a screenshot of this answer and complete it later because we need time to discuss that one. Or we just take a screenshot of this answer.
Done. Ma'am.
All right. Okay, class, use the raise hand emoji. Raise your hands. Use the emoji and raise your hands, class. Shruti, Ashwin. Okay, Shabari, okay. All right, children. Very good. Very good. I'll just unshare and share the other screen, children. Please hold. This one, right? Sorry, there was a delay in finding the file. Yeah, children, I think this was the one which we hadn't discussed in the last class.
Yes, ma'am.
All right, yeah. So have a look at the figure. What is given? AB is equal to 36 centimeters. AB is equal to 36 centimeters. All right. M is the midpoint of AB. Okay, M is the midpoint of AB. Find the area of the shaded region. Children, here the question, since I've written it out, I have just made it very short. Now these are semicircles. All that will be given to you in the question, children. All that will be given. You don't have to assume that they are semicircles. That will be given to you. So now I'm telling you, this is one large semicircle. This is one large semicircle, and inside that you have two smaller identical semicircles. We have two smaller semicircles, and you have one complete circle. One complete circle. Now the shaded region is this one. This portion is shaded. This portion is shaded, and this one is also shaded. All right. So this is the diameter. This is the diameter for this outer semicircle. This is the diameter for this outer semicircle. Okay. And now it's given that M is the midpoint of AB. M is the midpoint of AB. All right. But AB is 36 centimeters, which means AM is 18. MB is also 18. Okay. So now the diameter of each of these semicircles is 18 centimeters. The diameter of this semicircle is 18. The diameter of this semicircle is also 18. M is the midpoint. M is the midpoint. So 36. So this is 18 and this is 18. All right. So now, we see here for the semicircles, we know the radii. Now this is the big semicircle. We know its diameter and hence we know its radius. What else you need for a circle? That's all. Circle, if you have the radius, you can calculate anything. Area, perimeter, whatever you need to find about the circle, it's enough if you have the radius. So for the outer semicircle, we know the radius, we know the diameter, so we know the radius. For this semicircle, we know its diameter is 18 centimeters. So radius is 18 by 2, 9. And for the semicircle also, diameter is 18, so radius is 9. So for the three semicircles, we have the radius. Now for this circle, the radius of this circle is not known. So what is the idea, children? How do you find the area of the shaded region? This shaded region. How do you find the area of the shaded region? Tell me.
Area of the big semicircles minus the area of one circle minus the area of two semicircles, ma'am.
Very good. Yeah. So from the area of the big semicircle, if you take away the area of these two, if you take away the areas of these two small semicircles and the circle, you will be left with the area of the shaded region. In simple words, area of the shaded region is the area of the semicircle minus the area of these unshaded regions, minus the area of these unshaded regions, the area of the semicircle. The area of the semicircle minus the area of these unshaded regions. This one is not shaded. This one is not shaded. This one is not shaded. So from the total area, if you remove the unshaded regions, you will get the area of the shaded regions. All right. So it's so simple to work. You just need to find the radius of the circle. That's all. You just need to find the radius of the circle. That's not known. Once you find the radius of the circle, calculation is so simple. The idea is very simple. So now this question is only to find, understand how to find the radius of this circle. Children, my screen is visible, right? Am I audible?
Yes, ma'am.
Yes, ma'am.
All right, children. So now again, there is a theorem which you are not still introduced to. It's from the chapter circles. It's from the chapter circles, but I can just tell you now. So we all know what a tangent is to a circle. You know that a tangent is a line that touches a circle at exactly one point, right? A tangent is a line. It's not a line segment. A tangent is a line that touches a circle. or that intersects the circle at exactly 1 point. Now there is a relationship between the tangent and the radius in a circle. Just listen to me. Circle, we know that a tangent is a line that intersects the circle at exactly 1 point. Now we are going to make use of a theorem which says that the radius and the tangent at the point of contact make a right angle. We'll just take that alone now. Now the construction is, this is a symmetrical figure. You can fold it, it's symmetrical. This one is symmetrical. When you join Mn, Mn, it's a symmetrical one. Join Mn, that's the first thing. Join Mn. The center C will be given to you. C is the center of the circle. Or you can just mark a point and say, let that be the center. See here, children. So join Mn. C is the center of the circle. C is the center. If the center is not given, you just mark a point, call it C or call it O, whatever, and say, let that be the center. Join Mn. Now this one is the center of the circle, and also join DC. We're just trying to have a right triangle here. We don't know now it's a right triangle. We have a triangle now. By the way of this construction, we have a triangle. Understand that part. We have a triangle. Join Mn and this one. Join DC. Now, can you see? I'm just telling you how the proof goes. Now we have a triangle here. Now our intention is to prove that this angle is a right angle. This angle, that is angle CMD. We need to show that angle CMD is a right angle. See here, CMD, this angle is a right angle. If you show that this is a right angle, then this is a right triangle, and then our job is very simple. Very simple. So we just need to prove that this one is a right triangle. So how do we show that this is 90 degrees? So for that, we make use of this theorem, which says that the radius and the tangent at the point of contact make right angles with each other. That is, they make an angle of 90 degrees. So now see here, this is a semicircle. But anyways, you can look at this as a circle also. See here, the semicircle. It's a part of a circle. Now, can you see this line segment, Mn? That's a tangent segment that acts as a tangent segment. Tangent segment meaning like how you say line segment. A line segment is a part of a line. A tangent segment. Mn is a tangent segment. See, okay, let me call it tangent. This is a tangent, but since a tangent is a line, I can't say it's a tangent. I can't say it's a tangent segment. A part of the tangent. Now see here, children. So now just imagine this line. Just extend it like this. So it's like there's a circle. Just visualize a circle. This one is a tangent to the circle. See, complete the circle. Just complete the circle and visualize this line. This one will act as a tangent to the circle. It will touch the circle. It'll touch the circle at exactly 1 point. It'll have only 1 point in common with the circle. Now this one is a tangent and this DM is a radius. DM is the radius. This is a tangent. This line segment will not cross the circle. It will not get into the circle. It will just touch the circle. So now this is a tangent segment. This is the tangent segment. And this is the radius of the. See, we're looking at one circle. Take up one circle. This is a circle. To the circle, this is the radius. DM is the radius. And the tangent here. So here is a right angle. The angle between the radius and the tangent is equal to 90 degrees. That's a theorem. We will learn the proof also when we take up that chapter. The radius and the tangent at the point of contact are at right angles to each other. Make an angle of 90 degrees. So see here for now, DM is the radius. And at M is the point of contact. See, this is the tangent. M is the point where the tangent touches the circle. So the tangent, see, this is the tangent. From the tangent to the radius, 90 degrees. We say that angle DMN is 90, where DM is the radius, Mn is a tangent. DM is the radius, DM is a radius, MN is a tangent segment. Now angle DMN, that angle between the radius and the tangent, angle DMN is 90 degrees. So angle DMC is a right triangle. And sorry, triangle DMC is a right triangle. Now let's use Pythagoras theorem. To use Pythagoras theorem, let's just find out the expressions for the different sides of the triangle. See, step 1 is to, after the construction, after just joining the required line segments, we need to show that this angle is 90 degrees. That's easy because DM is a radius, MN is a tangent. So angle DMN is equal to 90 degrees by the theorem. Okay, so now we've shown that this is a right triangle. Now let's take up the different sides of this triangle. DM is a side. How much is DM, children? How much is DM? What's the length of
9
DM?
centimeters.
9. It's 9. DM is 9. Okay, so DM is 9. Straight away, DM is 9. What about DC? What about DC? How much is D to this portion? This is the radius, right? This is the radius. See, from D to here is the radius. So since DM is 9, this portion, this is the radius of the semicircle. This will be 9. So DC will be 9 plus the radius. If we'll call the radius of the circle to be R. We'll call the radius of the circle to be R. So from here to here is 9. 9 plus R is DC. DC is 9 plus R. Let's see how again. See here. From here to here is 9. Because for the semicircle, this line segment is a radius. So since DM is 9 radius, this is also the radius 9. 9 plus R. 9 plus R. Yes or no, children? 9 plus R, yes or no? DC is 9 plus R. From here to here is 9. And this is R, 9 plus R. And what about CM? We need to find CM. How much is MN, children? How much is MN? How much is MA? How much is MA?
18, ma'am.
80.
MA is 18. Then what is MN? That's also the radius, right, of the same semicircle. MN. M is a midpoint. M is a center. MN is a radius. Same thing, 18. So 18, this MN is 18. 18 minus R. Because this is the center, this is the radius of the small circle. The full thing is 18 minus R will be MC. What is MC? MC will be MN minus NC. MC will be the whole thing MN 18. Because MN is 18 because MA is 18. MB is 18. So MN also radius 18. 18 minus the radius of the circle. 18 minus R will be MC. Will be MC. So like this, you have to find the numerical values or expressions for the sides. Like this, you have to find, either directly the numerical values or some expressions for the sides and then use Pythagoras theorem. So DM is 9 centimeters. MC is 18 minus R is MC. And then DC is from here to here is 9 plus R. So having got these expressions for the sides, now use Pythagoras theorem. Write out the rule by Pythagoras theorem. Substitute. And then, you get R is 6. Now you got, see, that's what we understood. For the two semicircles, for everything we know the radius. There are 3 semicircles. We know the radius of all the 3. We don't know the radius of this circle. That is what we found first. That is what we need to first find. By, we do some construction and then we take up a triangle from there. We show it's a right triangle and then use Pythagoras theorem. And having found the radius, it's simple to find the area of the shaded region. I found all the answers in pi. I'll share this answer alone since it's time. I'll share this answer alone. So I found all the answers in pi and then subtract from the area of the semicircle, take away all this to find the area of the shaded region. I got the answer in pi and then use the value of pi 3.14. All right, children. So that's it for today's session. If you have any questions, stay back, else you may leave the meeting, children. Thank you. I'll share this working alone. Please complete it later.
Thank you, ma'am.
Yeah.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Thank you, children. Thank you. Good night.
Thank you.
Thank you. Good night.
Thank you, ma'am.
Thank you.